Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P4 Variant 2 May-June 2020. Let's get started. Divide $24 in the ratio 7:5. For the first split, we have 7 divided by the total ratio, which is 7 plus 5 times $24, which gives us $14. And for the second split, we have 5 divided by the total ratio times $24, which gives us $10. Write $24.60 as a fraction of $2,870. Give your answer in its lowest terms. In setting up the fraction, the number after the of, which is $2,870, will be our denominator. And so we have $24.60 divided by $2,870, which gives us 3/350. Write $1.92 as a percentage of $1.60. In setting up the percentage, the number after the of, which in this case is $1.60, will be our denominator. And so we have $1.92 divided by $1.60 times 100%. When we type this into the calculator, we get 120%. In a sale, the original prices are reduced by 15%. Calculate the sale price of a book that has an original price of $12. To get the sale price, we subtract 15% from 100%, which is the same as 85%, and multiply it by the original price, which is $12. This gives us the sale price as $10.20. Calculate the original price of a jacket that has a sale price of $38.25. This time around, we've been given the sale price and we are asked to find the original price. A 15% reduction in the original price means that 85% of the original price is equal to $38.25. After we make the original price the subject of the equation, we get $45 as the original price of the jacket. Dean invests $500 for 10 years at a rate of 1.7% per year simple interest. Calculate the total interest earned during the 10 years. We can find the total interest using this formula. P, which is the principal or the initial amount of money put into the investment, has been given as $500. R is the rate, and that is 1.7. T is the time duration for the investment, and that is 10. When we type this into the calculator, we get the total interest as $85. Oli invests $200 at a rate of 0.0035% per day compound interest. Calculate the value of Oli's investment at the end of 1 year. 1 year equals 365 days. In this scenario, the investment is based on compound interest, and so we need to use this formula. Since the rate has been given as 0.0035% per day, then the time duration also needs to be converted to days, which in this case, 1 year equals 365. The small a in the formula represents the principal, and that is $200. The big A represents the amount of money at the end of the investment, which is what we are finding. So when we type this into the calculator, we get $202.57, correct to 2 decimal places. Edna invests $500 at a rate of R% per year compound interest. At the end of 6 years, the value of Edna's investment is $559.78. Find the value of R. We are dealing with a compound interest scenario in this case as well, but this time around we need to find R. When we make R the subject of the equation, this is what we get. Big A represents the total amount of money at the end of the investment, which is $559.78. Small a represents the initial amount invested, which is $500. T is the time duration, and that is 6. So when we type this into the calculator, we get R equals 1.90, correct to 3 significant figures. P equals 45. Q equals -27. Find 2P plus Q. For the top element of the resulting vector, we have 2 times 4 plus -2, which gives us 6. And for the bottom element, we have 2 times 5 plus 7, which gives us 17. And so our final answer here is 617. Find the magnitude of vector P. The magnitude of P is the square of the top element, which is 4, plus the square of the bottom element, which is 5. This gives us 6.40, correct to 3 significant figures. A is the point 41 and vector AB equals -3, 1. Find the coordinates of B. If the x-coordinate of point A is 4 and the vector AB tells us we need to move -3 units along the x-axis to get to B, then the x-coordinate of B will be 4 plus -3, which is the same as 4 minus 3, and that is equal to 1. Then for the y-coordinate of B, we have 1 plus 1, which gives us 2. The line y equals 3x minus 2 crosses the y-axis at G. Write down the coordinates of G. At the point where the line crosses the y-axis, the x-coordinate is 0. To find the corresponding y-coordinate, we slot in x equals 0 into the equation of the line. This gives us 3 times 0 minus 2, which is equal to -2. And so the coordinates of G are 0, -2. In the diagram, O is the origin, OT equals 2TD, and M is the midpoint of TC. Vector OC is C, and vector OD is D. Find the position vector of M. Give your answer in terms of C and D in its simplest form. The position vector of M is the same as the vector OM. To get to M from the origin O, we can use the root OT plus TM. TM is half of TC and TC is TO plus OC. OT is 2/3 of D. TO is -2/3 of D, and OC is C. When we expand the brackets and group like terms, we get the vector OM as 1/3 of D plus half of C. The speed v kilometers per hour of each of 200 cars passing a building is measured. The table shows the results. Calculate an estimate of the mean. The mean is sigma f of x divided by sigma f. To get sigma f of x, we first need to calculate the average speed for each of the given speed intervals. So for the first interval, the average speed is 0 plus 20 divided by 2, which is 10. Then we have 20 plus 40 divided by 2, which is 30. 40 plus 45 divided by 2, which gives us 42.5. 45 plus 50 divided by 2, which gives us 47.5. 50 plus 60 divided by 2, which gives us 55. Then finally, we have 60 plus 80 divided by 2, which is 70. So now we have the mean as 10 times 16 plus 30 times 34 plus 42.5 times 62 plus 47.5 times 58 plus 55 times 26 plus 70 times 4 divided by 200. When we type this into the calculator, we get 41.4. Use the frequency table to complete the cumulative frequency table. For V is less than and equal to 45, we add up all the frequencies up to the point V is less than and equal to 45, which is 16 plus 34 plus 62. This equals 112. For V is less than and equal to 50, we add up all the frequencies up to the point V is less than and equal to 50, which is 16 plus 34 plus 62 plus 58. This equals 170. On the grid, draw a cumulative frequency diagram. On the grid, we plot the points 2016, 4050, 45 112, 50 170, 60 196, and 80 200. When we are done, we connect all the points with a smooth line starting from the origin. Use your diagram to find an estimate of the upper quartile. To get the upper quartile, we map 3/4 of 200, which is 150, on the diagram, and this gives us the upper quartile as 48 kilometers per hour. Use your diagram to find an estimate of the number of cars with a speed greater than 35 kilometers per hour. When we map 35 kilometers per hour on the diagram, we get 40. This means that the number of cars with a speed greater than 35 kilometers per hour is 200 minus 40, which is 160. 2 of the 200 cars are chosen at random. Find the probability that they both have a speed greater than 50 kilometers per hour. Using either the table or the diagram, we find that the number of cars with a speed greater than 50 kilometers per hour is 30. This means that for the first pick, the probability that the car chosen from the 200 cars has a speed greater than 50 kilometers per hour is 30 over 200. After the first car is picked, the pool reduces by 1, and so the probability that the second car also has a speed greater than 50 kilometers per hour is 29 over 199. When we type this into the calculator, we get 0.0219, correct to 3 significant figures. A new frequency table is made by combining intervals. On the grid, draw a histogram to show the information in this table. To be able to draw the histogram to show the information given in the table, we need to calculate the frequency density for each of the given intervals. The frequency density is equal to the frequency divided by the interval width. For the first interval, the frequency density is the frequency, which is 50, divided by the interval width, which is 40 minus 0, and this is equal to 1.25. Then we have 120 divided by 50 minus 40, which is equal to 12. Then finally, we have 30 divided by 80 minus 50, which is equal to 1. After marking all the different intervals on the horizontal axis of the grid, we can now map out their heights using their frequency density values. The diagram shows two triangles. Calculate QR. By looking at triangle PQR, we have the lengths of the other two sides of the triangle, and we've been given the angle opposite side QR. So straight away, we know that we can apply the cosine rule to find the length of QR. This is what we get when we apply the cosine rule. PQ is 120, PR is 150, and angle QPR is 25 degrees. When we make QR the subject and substitute these values into the equation, this is what we get. And when we type this into the calculator, we get QR equals 65.4 meters, correct to 3 significant figures. Calculate RS. From the diagram, we have the necessary information to be able to apply the sine rule to find the length of RS. This gives us RS divided by sine 55 degrees equals 150 divided by sine 80 degrees. When we make RS the subject, this is what we get. When we type this into the calculator, we have RS equals 125 meters, correct to 3 significant figures. Calculate the total area of the two triangles. All we need to do is apply the formula for the area of a triangle, which is half AB sine theta, to both of the triangles. For triangle PQR, we have half times 120 times 150 times sine 25 degrees. And for triangle PRS, we have half times 150 times 125 times sine 45 degrees. When we type this into the calculator, we get 10,400 meters squared, correct to 3 significant figures. The diagram shows a field ABCD. The bearing of B from A is 140 degrees. C is due east of B and D is due north of C. AB is 400 meters, BC is 350 meters, and CD is 450 meters. Find the bearing of D from B. This bearing is the angle we measure in the clockwise direction from the north of B to D. This has been indicated with a green arrow. We've been told C is due east of B and D is due north of C. This means that these two angles are each 90 degrees. If we label this angle as alpha, then it means the bearing will be 90 degrees minus alpha. Triangle BCD is a right-angled triangle, and so we can find the value of alpha by applying SOHCAHTOA. This gives us tan alpha equals the opposite, which is 450 meters, divided by the adjacent, which is 350 meters. When we make alpha the subject, we have tan inverse of 450 divided by 350. When we type this into the calculator, we get 52.1 degrees, correct to 1 decimal place. This means that the bearing is 90 degrees minus 52.1 degrees, which is equal to 37.9 degrees. Calculate the distance from D to A. We can easily find the length of BD and angle ABD, which means to find the distance from D to A, we need to use the cosine rule. When we apply the cosine rule to triangle ABD, this is what we get. We've already been given the length of AB, so let's find the length of BD. By applying the Pythagoras theorem to triangle BCD, this is what we get. BC is 350 meters and CD is 450 meters. And so when we make BD the subject and substitute these values into the equation, we get 50 root 130 meters. Angle ABD is 40 degrees plus the other angle which we found in the previous question as 37.9 degrees. This gives us 77.0 degrees. So now when we make DA the subject and substitute these values into the equation, we get 624 meters, correct to 3 significant figures. Jono runs around the field from A to B, B to C, C to D, and D to A. He runs at a speed of 3 meters per second. Calculate the total time Jono takes to run around the field. Give your answer in minutes and seconds, correct to the nearest second. We know the formula speed equals distance over time. When we make time the subject, we have distance divided by speed. The distance traveled is equal to the distance from A to B, which is 400 meters, plus BC, which is 350 meters, plus CD, which is 450 meters, plus DA, which we found in the previous question as 624 meters. This gives us 1824 meters. Since we've already been given the speed at which he was running as 3 meters per second, we have t equals 1824 divided by 3 seconds, which is equal to 608 seconds. To convert to minutes, we divide 608 by 60. This gives us 10^2/15 minutes. We need to multiply 2/15 by 60 to convert it to seconds. This gives us 10 minutes, 8 seconds. Find h of 4. To find h of 4, we replace x with 4 in h of x. This gives us 4 raised to the power 4, which is 256. Find f of g of 1. First, we need to find g of 1, which is 1 squared plus 1, giving us 2. This means to get f of g of 1, we put g of 1, which is 2, into f of x, giving us 3 times 2 plus 2, which is equal to 8. Find g of f of x in the form ax squared plus bx plus c. To get g of f of x, we take out x in g of x and replace it with f of x, which gives us 3x plus 2 squared plus 1. To expand the square brackets, we square 3x, giving us 9x squared. Then we multiply 3x and 2, multiplied by 2, which gives us 12x. Then we square 2, which is 4. 4 plus 1 is 5, and so our final answer here is 9x squared plus 12x plus 5. Find x when f of x equals g of 7. F of x is 3x plus 2 and g of 7 is 7 squared plus 1. When we subtract 2 from both sides, we get 3x equals 48. When we divide both sides by 3, we get x equals 16. Find f inverse of x. To get f inverse of x, we replace f of x with x and replace x with y. When we make y the subject of the equation, we get y equals x minus 2 over 3, which is the same as f inverse of x. And so f inverse of x is also equal to x minus 2 over 3. Find g of x over f of x plus x. Give your answer as a single fraction in terms of x in its simplest form. When we substitute g of x and f of x into the expression, we get x squared plus 1 divided by 3x plus 2 plus x. The LCM is 3x plus 2. 3x plus 2 goes into the LCM one time. 1 times the numerator gives us x squared plus 1. X has 1 as the denominator. 1 into 3x plus 2 is 3x plus 2, which multiplies the numerator to give us x times 3x plus 2. When we expand the brackets, x times 3x is 3x squared and x times 2 is 2x. When we group like terms, x squared plus 3x squared is 4x squared, and so our final answer here is 4x squared plus 2x plus 1 divided by 3x plus 2. Find x when h inverse of x equals 2. To find h inverse of x, we replace h of x with x and replace x with y. Y is the same as h inverse of x, which has been given as 2. And so we have x equals 4 raised to the power 2, which is equal to 16. Tanya plants some seeds. The probability that a seed will produce flowers is 0.8. When a seed produces flowers, the probability that the flowers are red is 0.6, and the probability that the flowers are yellow is 0.3. Tanya has a seed that produces flowers. Find the probability that the flowers are not red and not yellow. The sum of the probabilities must be equal to 1. And so the probability that Tanya's seed produces flowers that are neither red or yellow is 1 minus 0.6 plus 0.3, which gives us 0.1. Complete the tree diagram. The sum of probabilities of a set of branches must be equal to 1. So for this, the probability that the seed does not produce flowers is 1 minus 0.8, which is 0.2. For this, we've already been given the probability that the flowers are red as 0.6 and the probability that the flowers are yellow as 0.3. And we already found the probability that the flower is any other color as 0.1. Find the probability that a seed chosen at random produces red flowers. This probability is equal to the probability that the seed produces flowers in the first place and that these flowers are red. The probability that the seed produces flowers is 0.8 and the probability that these flowers are red is 0.6. 0.8 times 0.6 is 0.48. Tanya chooses a seed at random. Find the probability that this seed does not produce red flowers and does not produce yellow flowers. For this probability, we have two scenarios. In the first scenario, the seed does not produce flowers, and for the second possible scenario, the seed produces flowers and the flowers are neither red nor yellow. From the tree diagram, we know that the probability that no flowers are produced is 0.2. The probability that flowers are produced is 0.8. And the probability that these flowers are neither red nor yellow is 0.1. When we type this into the calculator, we get 0.28. Two of the seeds are chosen at random. Find the probability that one produces flowers and one does not produce flowers. This is pretty straightforward, but we need to be careful because we have to take into account the order in which the seeds are picked. This means the seed that produces flowers is picked first and the one that does not is picked second, or the seed that does not produce flowers is picked first and the one that produces flowers is picked second. By substituting the values from the tree diagram, we can write the probability as this. When we type this into the calculator, we get 0.32. Triangle ABC is mathematically similar to triangle PQR. The area of triangle ABC is 16 centimeters squared. Calculate the area of triangle PQR. For the two similar triangles, we can set up our equation like this. The area of triangle PQR divided by the area of triangle ABC should be equal to one of the side lengths in triangle PQR divided by its corresponding length in triangle ABC. Since we are dealing with area, we need to square the side lengths of the two triangles. We want to find the area of triangle PQR, so we make that the subject of the equation. When we substitute the values of PQ, AB and triangle ABC into the equation and type the resulting expression into the calculator, we get the area of triangle PQR as 36 centimeters squared. The triangles are the cross-sections of prisms which are also mathematically similar. The volume of the smaller prism is 320 centimeters cubed. Calculate the length of the larger prism. Since the prisms are also mathematically similar and we've been given the volume of the smaller prism, we can easily find the volume for the large prism, which we can then use to find its length. For the two similar prisms, we have the volume of the large prism divided by the volume of the small prism equals one of the side lengths in the large prism divided by its corresponding length in the small prism. Since we are dealing with volume in this case, we need to cube the side lengths of the two prisms. When we make the volume of the large prism the subject of the equation and substitute the values of PQ, AB, and the volume of the small prism, we get the volume of the large prism as 1080 centimeters cubed. We can now find the length of the prism by using the volume of a prism formula. When we make the length the subject of the formula and substitute the values for the volume and the cross-sectional area, we get 30 centimeters. A cylinder with radius 6 cm and height h cm has the same volume as a sphere with radius 4.5 cm. Find the value of h. Okay, so we know that the volume of the sphere and the volume of the cylinder are equal. The volume of a cylinder is pi r squared h and the volume of a sphere is 4/3 pi r cubed. The radius of the cylinder is 6 centimeters and the radius of the sphere is 4.5 centimeters. 6 squared is 36 and 4/3 times 4.5 cubed is 121.5. When we divide both sides of the equation by 36 pi, this is what we get. Pi cancels out, and when we type 121.5 over 36 on the calculator, we get 3.375 centimeters. A solid metal cube of side 20 centimeters is melted down and made into 40 solid spheres, each of radius r centimeters. Find the value of r. Since the cube is melted to make the 40 spheres, it means the volume of the cube is equal to 40 times the volume of the sphere. The volume of a sphere is 4/3 pi r cubed. 40 times 4 is 160. We want to find the radius of the spheres, so we need to make r the subject of the equation. The volume of the cube is the cube of its side length, and so we have 20 cubed. When we type this into the calculator, we get 3.63 centimeters, correct to 3 significant figures. A solid cylinder has radius x centimeters and height 7x/2 centimeters. The surface area of a sphere with radius r centimeters is equal to the total surface area of the cylinder. Find an expression for r in terms of x. We've been told that the surface area of the sphere is equal to the total surface area of the cylinder. The cylinder has been described as a solid cylinder, and so for its total surface area, we need to take into account the surface area of the two circles above and below the cylinder, which gives us 2 times pi r squared, where r has been given as x. In addition to the curved surface of the cylinder, which is 2 pi r h, where r has been given as x and h has been given as 7x/2. The surface area of the sphere is 4 pi r squared, where we've been told to take the radius as big R. From here, we need to simplify the equation and make big R the subject of the equation. When we simplify the expression on the right-hand side, we have 7 pi x squared plus 2 pi x squared. 7 pi x squared plus 2 pi x squared gives us 9 pi x squared. When we divide both sides of the equation by 4 pi, this is what we get. Pi cancels out, leaving us with numbers that are all perfect squares. 9 is 3 squared and 4 is 2 squared. And so we can rewrite this as r squared equals 3x/2 all squared. When we take the square root of both sides of the equation, we have r equals 3/2x or 1.5x. Write x squared plus 8x minus 9 in the form x plus k squared plus h. To do this, we need to go through the process of completing the square. Another way to go about this is to expand x plus k squared plus h and compare it with x squared plus 8x minus 9 to find the values of k and h. In this case, we are going to use the completing the square approach. So first, we take the coefficient of the x term, which is 8, divide it by 2 and square it. Then we add and subtract it to balance the expression. Now that we have the expression in this form, this first section of the expression can be rewritten by taking the x of the x squared, then taking the constant term 8 over 2, which is 4, then writing it as x plus 4 all squared. When we type the other section of the expression, which is negative 8 over 2 all squared minus 9 into the calculator, we get negative 25. And so our final answer here is x plus 4 squared minus 25. Use your answer to part AI to solve the equation x squared plus 8x minus 9 equals 0. Based on the answer we got in part AI, we can rewrite the equation as x plus 4 squared minus 25 equals 0. When we add 25 to both sides of the equation, this is what we get. When we take the square root of both sides of the equation and subtract 4 from both sides, this is what we get. For the first x value, we have positive square root of 25, which is 5 minus 4. 5 minus 4 is 1. For the second value of x, we have negative square root of 25, which is negative 5 minus 4, which gives us negative 9. The solutions of the equation x squared plus bx plus c equals 0 are negative 7 plus square root of 61 divided by 2 and negative 7 minus square root of 61 divided by 2. Find the value of b and the value of c. Due to the nature of the solutions, we can easily find the values of b and c by comparing it to the quadratic formula. When we do this, we can straight away see that the value of b is 7. For the denominator, 2a must be equal to 2, and so a equals 1. b squared minus 4ac must be equal to 61. When we substitute the values of b and a into the equation, this is what we get. When we simplify the equation and make c the subject, we get negative 3. And so the values of b and c are 7 and negative 3. On the diagram, sketch the graph of y equals x minus 1 squared. First, let's determine the coordinate of the turning point of the quadratic function. We get the x-coordinate of the turning point by equating x minus 1 to 0, which gives us x equals 1. And since there is no constant adding or subtracting x minus 1 squared, then the y-coordinate of the turning point is 0. And so the coordinate of the turning point is 1, 0. This means the curve sits above the x-axis. At the point where the function crosses the y-axis, the x-coordinate is 0. When we substitute x equals 0 into the equation, we get the corresponding y-coordinate as 1. And so the coordinate of the point where the curve cuts the y-axis is 1, 0. After plotting these points, we draw a smooth line passing through the points. On the diagram, sketch the graph of y equals half x plus 1. We can draw the graph of any straight line by finding the coordinate of 2 points that lie on the line. When we substitute x equals 0 into the equation of the line, we get the corresponding y value as 1. So we can plot 0, 1 on the diagram. When we substitute x equals negative 2 into the equation, we get y equals 0. And so we plot negative 2, 0 on the diagram. Now all we need to do is draw a straight line passing through the 2 points. The graphs of y equals x minus 1 squared and y equals half x plus 1 intersect at A and B. Find the length of AB. We can find the points of intersection by solving the equations of the two graphs simultaneously. When we put equation 1 in equation 2, we get x minus 1 all squared equals half x plus 1. When we expand the square brackets, we get x squared minus 2x plus 1. When we group like terms, we get x squared minus 5 over 2x equals 0. We can easily solve this quadratic equation by factorization. When we factor out x, we are left with x minus 5 over 2. From here, we get x equals 0 and x equals 2.5. To get the corresponding values of y, we substitute the x values into either equation 1 or equation 2. Let's pick equation 1. And so when x equals 0, we get y equals 1. And when x equals 2.5, we get y equals 2.25. Now that we have the coordinates of points A and B, we can find the length of AB by using the length or distance formula. This gives us AB equals square root of 2.5 minus 0 all squared plus 2.25 minus 1 all squared. When we type this into the calculator, we get AB equals 2.80, correct to 3 significant figures. Y equals x raised to the power 4 minus 4x cubed. Find the value of y when x equals negative 1. When we substitute x equals negative 1 into the equation, this is what we get. When we type this into the calculator, we get y equals 5. Find the two stationary points on the graph of y equals x raised to the power 4 minus 4x cubed. At any stationary point, dy dx equals 0. When we differentiate y equals x raised to the power 4 minus 4x cubed, we get dy dx equals 4x cubed minus 12x squared, which we equate to 0. 4x squared is common to both terms, and so when we factor that out, we are left with x minus 3. When we equate 4x squared to 0, we get x equals 0. And when we equate x minus 3 to 0, we get x equals 3. Now that we have the x coordinates of the stationary points, we need to find their corresponding y coordinates by substituting the x values into the equation of the function. So when x equals 0, we have y equals 0. And when x equals 3, we have y equals negative 27. Y equals x raised to the power p plus 2x raised to the power q. Dy dx equals 11x raised to the power 10 plus 10x raised to the power 4, where dy dx is the derived function. Find the value of p and the value of q. We need to differentiate y. For x raised to the power p, the power p multiplies the coefficient of x, which is 1, giving us p. Then we subtract 1 from the power, giving us p minus 1. For 2x raised to the power q, q multiplies the coefficient of x, which is 2, giving us 2q. Then we subtract 1 from the power, giving us q minus 1. When we compare this to the results, we see straight away that p equals 11 and 2q equals 10, which gives us q equals 5. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.